Hello everyone from calculatoalgebra.org. We are now covering our second part of computing trigonometric functions from right-angle triangles. Now, suppose that again we have a problem where we're asked to compute a trigonometric function from a right-angle triangle, but we don't know the two legs of the triangle. We only know, say, one leg and a hypotenuse. This is the general premise, but this premise can be camouflaged a little bit. Let's see how. Let's read this particular problem. Suppose that cosine of theta equals 2/5. Right, so we're not given any triangle. We're just given the value of a cosine function. There's something else in this problem. Suppose we're given that cosine of theta is 2/5, but theta is not just any angle. Of course, there are infinitely many angles whose cosine is 2/5. Right? Just take any angle and add 360 degrees to it. There are other ways, of course, not only that. So there's not only one angle with that cosine, but among all possible angles, we're selecting one which lies between 0 and pi over 2. Pi over 2 is 90 degrees, all right? So we're selecting the angle between 0 and pi over 2 for which cosine of that angle is 2/5. By the way, I said the angle, which implies that there is only one such angle. Indeed, that is the case, but let me not prove that. Okay, there's one angle between, say, one angle between 0 and 90 degrees. Theoretically, there could be more than one. In a theoretical section, we can prove that there can be only one angle with this property, but let's just ignore that for the time being. All right, now. So we know that the cosine of our angle is 2/5. Let's now. So what does the problem ask us to do? It asks us to find the other 5 trigonometric functions of the variable theta. All right. So let's do that. Now, how should we proceed? Well, so far we know how to find trigonometric functions on condition that our angle is a part of a right-angle triangle. Let's construct that right-angle triangle. So here I have drawn a right-angle triangle that includes the angle theta. This is up to scale, by the way. So you may think, well, how did I draw that triangle, right? So how did I tell my computer to draw an angle whose cosine is 2/5? Or how did I guess that angle? Well, here's what I did. See, the thing is that if I take a triangle whose hypotenuse is 5 units and whose adjacent leg is 2 units, then I'm guaranteed that the angle adjacent to the leg 2 and the hypotenuse of 5, I'm guaranteed that that angle, its cosine must be 2/5, right? So I'm guaranteed that if I can construct an angle with hypotenuse 5 and adjacent leg 2, then that right angle triangle will correspond to the trigonometric functions that I'm seeking to find, right? Let's see how that goes. So how did I actually draw that triangle? Okay, so so you're gonna say, well, I told my computer here to draw 2 units horizontally. That's clear. It's clear how to do that. But how did I tell my computer to find this particular point over there? How did I do that? Well, see, I know the x-coordinate of that point. It's going to be 2 units, right? I'm moving 2 units to the left of that point, so that's easy to tell your computer how to draw that. But what's the height? What's the height of that triangle, right? For me to be able to draw that triangle even, so for me to be able to even generate that picture, I need to know the height of the triangle. Let's label that height as x. Yeah, we do need that height in order to figure out the trigonometric functions from the angle theta. All right. So now again to our aid comes the Pythagorean theorem. Now let's see. The Pythagorean theorem says that this leg of our right angle triangle squared plus that leg of our right angle triangle squared must be equal to the hypotenuse squared. So my Pythagorean theorem says that x squared, that unknown leg here, plus 2 squared, that known leg here squared, must be equal to 5 squared. So from the Pythagorean theorem, x squared plus 2 squared equals 5 squared. All right. And now let's see what that means. Well, if x squared plus 2 squared equals 5 squared, well, 2 squared, that is 4. So x squared plus 4 must be equal to 25, right? 5 squared is 25. From here, it follows that x squared must be equal to 21, right? Because you can take the 4 and transfer it on the other side. So we get that x squared must be equal to 21. And from there, of course, it is easy to conclude that if x squared equals 21, well, then x, by the rules of algebra, that must be equal to plus or minus radical of 21, right? But we can discard minus 21 because x is it is a length of a side of a triangle, so we can discard the minus. So lengths are always positive by definition. So we do not need to include any signs. All right. So now we are in the good old situation where we have our angle theta, and we have managed to fit it in a right angle triangle, and something more, a right angle triangle in which we know all 3 sides, the hypotenuse, the opposite, and the adjacent side. So the rest should be easy. Let's see, what is sine of theta equal to? Well, sine of theta, that is the opposite side over the hypotenuse, so that should be a radical of 21 over 5, right? Now, tangent of theta. What was tangent of theta equal to? Well, tangent of theta, that was, let me see, tangent of theta, that was the, which side over which was it? I'm sure you guessed it, the opposite side over the adjacent side. So the opposite side over the adjacent side. So that should be radical of 21 over 2. All right. Cosecant of theta, what was cosecant of theta equal to? Well, cosecant of theta, that was 1 over sine of theta, which, well, in this case, we can just directly say that that's 5 over radical of 21. Okay? And secant of theta, well, secant of theta, that was 1 over cosine of theta, right? Or if you wish, that would be, let's see, that would be the hypotenuse over the adjacent leg. So secant of theta, that must be, what is it? I'm sure you guessed it. It must be 5/2, right? So 1 over cosine of theta. So here's cosine of theta. It's 2/5. So 1 over 2/5 is, of course, 5/2. All right. And finally, cotangent of theta. Well, cotangent of theta, that's 1 over tangent of theta. Or if you will, well, what's the same? You can take the adjacent side and divide it by the opposite side. And you'll be getting, well, I guess you'll be getting the adjacent side is, I'm sure you guessed it. So the adjacent side is 2 units, and the opposite side is radical of 21 units. So there we go. That's our cotangent. All right, so here's how this problem goes. Let's take a look at the corresponding problem on our homework server. So now I'm going to switch to our homework server, and there we're going to solve a similar problem. All right. So here's the problem I want to solve. I'm going to open it in a new tab. There we are. All right. So now what you're going to notice is that in this particular problem, So the right angle triangle is not aligned neatly. That is on purpose. That is just camouflage seeking to distract you. Okay. So the angle theta is in a weird position as well. Okay. So that is just on purpose. Let's see what kind of a situation we have here. Now, let theta be the angle indicated in the plot above, so that would be this angle theta. Let's find the indicated trigonometric function, so the remaining, the 6 trigonometric functions. Now, this problem is not stated in the exact same way as the problem in the slides, but it's very similar in the sense that we know the hypotenuse, that's given to us to be 14 units, and we know one of the two legs, that's given here to be 3 units. So that problem, just as in the slides, requests us to find the third angle of our right angle, the third side of our right angle triangle, this particular side. So we need to find that side as a function of the hypotenuse and the other leg. So let's see how that works. Well, that side here must be equal. That's actually the adjacent side, right? So here's the angle theta, so that's the adjacent side. So our adjacent side equals a radical of the hypotenuse squared, 14 squared, minus the opposite side squared, minus 3 squared, right? Here what I'm doing is I'm doing a radical of the hypotenuse squared minus the opposite square. That's what I'm doing here, right? And that equals radical of 19 squared. Well, that's, as we remember our squares, that's 196 minus 9. So that equals 1, let's see if I'm not mistaken, 187. Am I correct there? 187 plus 9 is 196, so radical of 187. Okay, so our hypotenuse is a radical of 187. Sorry, our leg is a radical of 187. So let me do that. So radical of 187, that's our hypotenuse. That's our adjacent leg. Our opposite leg here, our opposite leg is 3, and our hypotenuse, here is our hypotenuse is 14. All right. So let's see, now this information is neatly visible here. So let's enter it. Our sine that was, sine is the opposite side divided by the hypotenuse. So the hypotenuse was 14 units. The opposite side is 3 units, so 3/14ths, right? So 3/14ths should be our sine. Let's check that. All right, that was correct. Okay, now next is cosine of theta. Cosine of theta. Well, if you remember, that was the adjacent side of the hypotenuse. So we saw that the adjacent side was the radical of 187, and we need to divide it by hypotenuse, which is 14 units. All right, that went through as well. Good for us. Next, we need to work out tangent of theta. Tangent of theta, just to remind you, that was what over what? Thank you. Opposite over adjacent. So that should be 3 divided by a radical of 187. Some of you were asking what happens when we have radicals in the denominator. Well, if we click the interpret button, we're going to be getting 3 over, so radicals in the denominator will automatically get rationalized by our system, so I don't need to do that extra step. But on an exam, you do want to transform 3 over radical of 187 into 3, so you want to transform 3 over radical of 187. You do want to transform that into 3 times radical of 187 divided by 187. And you can see that transformation is automatically done for you by the calculator. Okay, that went through as well. Now cotangent of theta, well, that's tangent of theta, so that is that's 1 over tangent of theta, right? So a radical of 187 divided by 3, so I just took that number and I flipped the denominator and the numerator, so I flipped the 2, and there we go, my answer is correct. Now secant of theta, that was 1 over cosine, so secant of theta, that's 1 over cosine of theta, which is hypotenuse over adjacent. So the hypotenuse was 14, and I need to divide by the adjacent one, which was radical of 187. Alright, that's marked as correct as well. And finally, cosecant of theta, that was 1 over sine, so that would be 14 thirds. Alright, we're done with this problem. Thank you for your attention and good luck with your homework.